Now, I'm pretty sure that there are people in my YouTube audience that are sitting there going, hey man, can't we talk about anything other than functions? Well, not in this video. The reason for it is because that there are two theorems, the remainder and factor theorems, that really need to be discussed. We are moving on through calculus, so you need to know all this stuff. Alright. What is a polynomial? Now, I've talked about this before, and I probably will again. But a polynomial is a big old equation. Let's take this equation for example. 5x squared plus 6x plus 9. As you can see that there are variables here with different terms. This is raised to the power of 2. This is raised to the power of 1, so on and so forth. And so if you have a group of terms like this, you have a polynomial equation. Now we're going to divide it by this little number here. It's x minus 2. Okay? Now, it just so happens that this equation right here also happens to be a function. Okay? Now, the remainder theorem clearly states that if you have the f of x right here, if you take x minus r and divide this polynomial equation by x minus r, which in this case is 2, okay, then what you're going to have is the quotient, which is the answer, plus the remainder. Alright. We did this. We did this through synthetic division. We took all the numerical coefficients, the 5, the 6, the 9, divided them all by 2, and of course 5 times 2 is 10, and 10 plus 6 is 16, and 16 times 2 is 32, and 32 plus 9 is 41. And that 41 is your remainder. So then we have an equation, x minus 2 times 5x plus 16 will give you 5x squared plus 6x minus 32. Well, negative 32 plus positive 41 gives you the 9. Okay? Now then, isn't there some simpler way to find the remainder of this equation right here? You got your polynomial equation of 5x squared plus 6x plus 9. You're dividing it by x minus 2. Isn't there some other way to find that remainder of 41? Well, yes, there is. And here's how we're going to do it. We're going to replace x with r. Okay? So, if we subtract 2 from 2, it becomes 0. If we take 0 times the quotient, which is this 5x plus 16 that we had right down here, then 0 times 5x plus 16 is, of course, also 0. And all you have left after that is your remainder. So, let's try it in this equation over here. What we're going to do, I'm going to erase a whole bunch of stuff here. Watch this. Now then, this is originally 5x squared plus 6x plus 9. What we've done, we had this divided by x minus 2, just like this. So what we did was we took the 2, we put it over here. 2 squared is 4. 4 times 5 is 20. Plus 6 times 2 is 12. Plus 9. Well, 20 plus 12 plus 9 equals 41. Which is the remainder if you divide 5x squared plus 6x plus 9 by x minus 2. And there you have your remainder. Now, what would happen, just say hypothetically, we had plugged this 2 in here, and we ended up getting an answer of 0 instead of 41. Then we could have said that x minus 2 was a factor of 5x squared plus 6x plus 9. So if this answer is ever 0, then this is a factor of this. And there's your answer. So now you have a remainder theorem, and you also have a factor theorem. Remember, if you ever substitute that 2, like I did here, into an equation like this, and the answer comes out 0, then x minus 2 is a factor of that. Otherwise, you've just found the remainder of your division problem, your quotient. Okay? And there you have it. If you have any questions, leave me a comment. I'll go even slower than this if I have to. But I think you pretty much got the idea here. I will tell you more in a future video, so stay tuned.